All right, so in this video, we're going to talk about similar triangles. So we've already talked about what similar means this year. Reminder that similar means same shape, different size. So what we're going to notice is that if two triangles are similar, all the angles should be equal. So for similar figures, angles are always equal. So we want to know, are the two triangles below similar? So they'll be similar if all their angles are equal. So let's first start off by finding angle A. So we know from triangle sum theorem that all three angles have to add up to 180. So basically, angle A plus angle C plus angle B, which we know is 90 degrees, has to equal 180. And so if we combine those like terms, x plus 127 equals 180. And if we subtract 127, x is going to be 53. So the top angle A is 53 degrees. And you'll notice to find G, we're going to do pretty much the same thing. X plus 37 plus 90 equals 180. So you can see very quickly that angle G is going to be the same measurement as angle A. Angle G is also 53 degrees. So yes, the triangles are similar. So since they all have the same measurement, all of the angles, the triangles are similar. So we have what's called the angle-angle criterion, which tells us that two triangles are going to be similar if they have two pairs of corresponding angles that are equal. So it's enough to know that two of the angles are equal, two of the corresponding angles are equal, because that tells us automatically, because of triangle sum theorem, that the last angle will be equal as well when we do the math out. So to write a similarity statement, we always want to match up the corresponding angles. So I would say triangle ABC is similar to triangle, I have to go in the same order, GHK. So the way I just said this was purple, pink, blue is similar to purple, pink, blue. You can't write it out of order. It has to be in the same order. This symbol here means similar to. So in English, this whole statement says triangle ABC is similar to triangle GHK. And so when they ask for the similarity statement, they're asking for this statement here. So we know that in two similar triangles, the angles are equal. What do we know about their sides? Well, their sides are going to be proportional. This goes back to the scale factor, right? So when we were doing transformations, when we did dilations, we always had a scale factor. So to calculate the scale factor, we're going to take the ratio of the corresponding sides. So I'm going to do 6 over 3 because those are the matching sides of this triangle. So 6 over 3 is my first ratio. Then my next ratio is 8 over 4 of the corresponding sides. And so my last ratio is going to be 4 over x, because the corresponding sides should be proportional. So 6 over 3, 8 over 4, those all equal 2. So what does the missing value of x need to be? It needs to be 2, because if I did 4 divided by 2, I would get the scale factor of 2, which basically tells us that the dark triangle is 2 times bigger than the lighter triangle. So we need to know this fact. If two triangles are similar, their sides are proportional. And as we said before, their angles are congruent. So just a quick reminder, angles are congruent, or in other words, they're equal. So at first, I'm looking at these two triangles and I'm thinking, they're not similar because they only have one pair of angles that are the same. And I know that I need to have at least two pairs. But what I want to do is I actually want to find this angle, G, just to make sure. So let's do the triangle sum theorem. Let's do 30 plus 102 plus x equals to 180 and see what we get for x. So if we combine our like terms, we're going to get 132 plus x equals 180. And so if we finish solving, if we subtract 132 from both sides, we're going to get x equals 48 degrees. So in fact, these triangles are similar because I do have two pairs of congruent angles. So yes, they are similar because when you use triangle sum theorem, you find that angle G is 48 degrees, which gives you two pairs of congruent angles. And all you need to know is that there are two, and I misspelled that, two pairs of congruent angles. So we know the triangles are similar. As long as there's two pairs of congruent angles, you can tell that the two triangles are similar. So in this example, we know that the triangles are congruent, or are similar rather. So what we know automatically is the angles are also congruent. So in this example, we know that the angles are congruent because they're similar, and the sides are proportional. So that's what we know about similar triangles: congruent angles, proportional sides. So I want to kind of look and see what the scale factor is. So I'm going to compare two corresponding sides. I have 3 and 21 in corresponding spots. So that tells me my scale factor is 7. This triangle is 7 times bigger because 3 times 7 is 21. So that means to find x, I know that the corresponding side on the big triangle is 14. So I essentially am going to do 14 divided by 7. So x has to be 2 because x times 2 needs to be equal to 14. To find y, I'm going to take 1 and multiply it by 7. So y times 1 times 7 gives me y, so y needs to be 7, so that all the sides can be proportional. I wrote times 2 here, but I meant times 7. Now for the angles, I know all of the angles are going to be congruent. So let's first start in the triangle here, finding b. To find b, I'm going to do b plus 78 plus 63 equals 180. So I'm going to just do triangle sum theorem to find it. So b plus, that's going to give us 143. Nope, not 143. 141, which is going to tell us that b is equal to 39 degrees. So b is 39, which means d also needs to be 39 because corresponding angles are equal. And then for c corresponds with 63. So c needs to be 63 degrees as well because all of the corresponding angles should be equal.